In this session, we will do some problems based on displacement vector in 2 dimensions. Now, our displacement in 2 dimensions is not as simple as the displacement that we have seen in 1 dimensions, right? So before we talk about this displacement vector in 2 dimensions, let's recap what we learned in a displacement vector video. So displacement vector is given as, suppose if I have a coordinate system like this. This is a coordinate system, okay, and we have two axes, x-axis and y-axis. Now what is the displacement vector says? Displacement vector, suppose if I have the initial position, let's say this is initial position, initial, and this is a final position, okay. What does the displacement vector tells us is that the vector which starts from the initial position and ends at the final position. So this vector denoted by s bar over here is a displacement vector. So how will we find this displacement vector? Suppose the position, the initial position here and the final position are denoted by two position vectors. Okay, this is the origin and we have these two position vectors. Let's say this is the initial position vector and this is a final position vector. So I will write this as Ri bar and this as Rf bar. Now position vectors are from the origin itself. Now if you see here, I can use triangle rule of addition of vectors and write Ri bar plus S bar is equal to Rf bar. So that means what is S bar? S bar will become Rf bar minus Ri bar. So it is nothing but the change in the position vectors. So final position vector minus initial position vector is the displacement vector. Okay, this tells us this. So now let's look at the problems that we can encounter. Okay, so the type of problem you can encounter is like this. So let me change this initial position to some coordinates, right? Okay, so the problems will be in such a type that I will tell now. Suppose the coordinates of this are, let's say 1 and 5, and for this it is 4 and 2, 6 and 4. Okay, don't scale it accurately because the scales are not that much, which scales are not mattering much over here. Okay, so I will do this. Okay, what is the displacement vector? Now what is the displacement vector S bar? This is S bar, by the way. Now the displacement vector can be found out using this formula. S bar is equal to Rf bar minus Ri bar. So how will you do that? We can find out what is Ri bar and Rf bar. Ri bar is equal to I cap, sorry, this is 1 and 5. So in x direction 1 magnitude is there and in y direction 5 magnitude is there. So this is I cap plus 5 j cap, and in Rf bar it will be 6 I cap plus 4 j cap. So this is due to the resolution of vectors. Now what we will get after subtracting this Rf bar and Ri bar? So Rf bar minus Ri bar will be equal to this particular vector minus this particular vector. So now you have to subtract component wise. So from 6 you have to subtract 1. So I will get 5 I cap, and from 4 you have to subtract 5. So you will get minus j cap. So it will be 5 I cap minus j cap. So this is the displacement vector. So given 2 points you can find out the displacement vector, right? Okay, so now what we will see is can we find out the final position given the displacement vector? So I will do again the same problem. Okay, I will write this like this. This is the coordinate frame, okay, reference frame, and then there are these two vectors, position vectors. Let's say this is Ri bar, this is Rf bar. And as we have seen over here, this is 1 5 and this is 6 4. This is 1 5 and this is 6 4. So now instead of this, I will just give you the displacement vector, which is phi I cap minus j cap. So this displacement vector's magnitude is given to you, phi I cap minus j cap. Okay, now I will ask you, what will be the final position? Suppose if the initial position is I, then what will be the final position f, given the displacement vector as phi I cap minus j cap. So what will be the answer for this? Okay, we will do this again using the same formula, rf bar minus ri bar is equal to s bar. So this becomes rf bar is equal to s bar plus ri bar. Now from here you can see that rf bar can be written as s bar plus ri bar. So ri bar is, here I will write here ri bar as I cap plus phi j cap, because it has x component of 1 length and y component of phi length. So this becomes ri bar plus s bar. So this becomes phi and 1 should be added. So component wise addition is there, 6 I cap, plus component wise addition is there, phi and minus 1. If I add, we will get 4. So this is 6 4. So here these coordinates are 6 4. So as you can see in our previous case, these were the coordinates 6 4 of the final position. So now let's look at some 2 more questions based on this. Okay, actually it should be here xy only, not z. Okay, so these xy coordinates of 2 points A and B are given respectively as 1 2 and 6 4. The displacement vector from P to Q is, so first write the coordinates. Okay, so these coordinates are written with respect to the origin of certain axis. Okay, so let's say this is the coordinates of A and this is the coordinate of B. This is actually given, right? So let's denote this as RA bar, the position vector of the point A. So this will be I cap plus 2j cap, because 1 unit in x and 2 units in y. So then we have RB bar vector. RB bar vector can be written as 6 in x direction, 4 in y. So 6 I cap plus 4j cap. Now we know the position vectors, the displacement vectors formula, which is rf bar minus ri bar. So using this we can do that. Now here from point A to point B we have to find out the displacement vector. Okay, oh, why have we written from P to Q over here? It is not P to Q. Okay, it is from A to B. So from A to B, what will be the position, the displacement vector? So coordinates of B minus coordinates of A, or position vector of B minus position vector of A. So if we do this, what we will get? RB bar minus RA bar. So component wise you subtract this. So if I subtract 1 from this 6, I will get phi I cap. And if I subtract 2 from this 4, I will get 2j cap. So this is the answer. The displacement vector is phi I cap plus 2j cap. Let's go to the next question. So the displacement from P to Q is given by the displacement vector 2I cap minus j cap. If point P has coordinates 3 4, what are the coordinates of Q? Now here the question is slightly changed, right? Here the displacement vector itself has been given to us, which is s bar, which is 2I cap minus j cap, and point P's coordinates are given to us. Point P, these coordinates are 3 4. So again I can write P bar as 3I cap plus 4j cap. This is done. Now what will be the coordinates of Q? So Q bar vector we don't know, right? We don't know this Q bar vector. By the way, P bar vector is a position vector of point P and Q bar vector is the position vector of point Q. But now we know this formula that S bar is equal to Q bar minus P bar. So it will be Q bar minus q bar minus p bar. We know this. So using this, what we will do, we will find the q bar's vector, right? So q bar vector is equal to s bar plus p bar. So now this q bar vector we can find out. So this will be equal to s bar is 2 I cap minus j cap. So s bar is 2 I cap minus j cap plus p bar. So p bar is 3 I cap plus 4 j cap. Now upon addition we will get the q bar. So 2 and 3 if you add, we will get 5 I cap, and 4 and minus 1 you add means you get 3 j cap. So this is the q bar. Okay, this is the coordinate. Okay, this is the position vector of q. So the coordinates of q will be 5 and 3.